All right, welcome back, everybody. Today we're going to be doing section 7.4, and in this section we're going to get a couple new formulas for the area of a triangle. I'm sure you already know the standard formula, the 1/2 base times height, so we'll review that, but then we're going to get a couple other new formulas that right triangle trigonometry gives us. So it can be kind of handy if we don't know what the height of a triangle is, for example. But let me pull up the slides and we'll get started. All right. So we're going to review the standard area formula, and we're actually going to prove it. It's a very short proof. If you've never seen it before, you should always see it at least once. So that's why I wanted to go over it. Then we're going to figure out how we can find the area of SAS triangles. That's triangles where we know two side lengths and the included angle. Then we're going to get a new area formula, new to us, called a Heron's formula. And then we'll be able to find the area of SSS triangles. So let's say you've got a triangle and all you know are the side lengths. We can compute the area of that triangle using Heron's formula. So here we go. What is the standard area formula? This is the one I'm assuming you're all familiar with from when you learned it way back in grade school. The area K of a triangle is 1/2 base times height, where B is the base of the triangle and H is the height of an altitude drawn to that base. So for example, if you wanted to know the area of just some random triangle, like that, maybe one that's not so nice looking. There we go. Like, what's the area of that triangle? Well, you would need to know this length, and you would also need to know the length of this altitude. And then the area of the triangle is going to be 1/2 b times h. But sometimes you don't know h. That's kind of the tricky part, right? If you don't know what h is, it can be difficult to find what the area is, unless you've got some trigonometry at your disposal. But let's look at the proof. 1/2 base times height. Why is that the formula itself? So the proof is actually very short. In the figure below, triangles 1 and 2 have equal area. So this triangle and this triangle, they have the same area. And triangles 3 and 4 have the same area. So this triangle and this triangle both have the same area. Now, the area of the rectangle that's formed by all 4 of those triangles is b times h, right? So it's like, let's say we want to know the area of this triangle right here, the one that I just circled. Well, you essentially construct a rectangle where that triangle's like circumscribed inside that rectangle. The area of this rectangle here is just base times height, length times width, right? Good old area of a triangle. Now, do this right here. So we know the area of that rectangle is base times height. But since these triangles here have the same area, it's basically that area doubled. And these triangles here have the same area, so it's like that area doubled. That means that the area of the triangle formed by these right here, the triangle that we're interested in, has got to be exactly half the area of the rectangle. So in other words, the area of this triangle is going to be half base times height. And that's where the formula comes from. 1/2 base times height. And that works for any triangle at all, as long as you know B and you know H. All right, so now with that standard area formula, we can leverage what we know about right triangle trigonometry to express it in this way. So let's say we have a triangle with side lengths A and B. One of those is not necessarily an altitude, but let's say we also know the included angle between them, the angle C. Then the standard area formula gives us that the area of the triangle must be 1/2 AB sine C. 1/2 AB sine C. There we go. And we're going to prove this right now too. Although maybe if you think about the picture, the proof will not be too difficult to surmise, right? But here we go. Using the standard area formula and right triangle trigonometry, right? Here's what we know so far. We know, oops, right? We know this, and we know this, and we know this angle C. Well, with that information, we can find what the area is because we know that this length h right here, in fact, let me do this. This length h, well, this is the leg of a right triangle. Leg of a right triangle, right? And what does right triangle trigonometry say? It says, well, the sine of the angle C is opposite over hypotenuse. Let me write that right here. Sine of C equals opposite over hypotenuse. But we know what the length A is, so that tells us that H is going to be equal to A times sine of C. So this length right here is A times sine of C. All right, now we can plug that into the standard area formula, move some things around a little bit, and we get this formula, 1/2 AB sine C. There we go. So this is great because what this gives us is a formula to find the area of a triangle when all you know is the length of two sides and the size of the angle included in between them, which is pretty handy, right? So let's use it. Let's find the area of this triangle where one length, one side has length A, one side has length 5, one side has length 3, and the included angle is 60 degrees. Here we go. Actually, you know what? Try this one on your own. I'll jump straight to this. I bet if you thought about it, you could work it out pretty quickly. Try it out. How would you do it? All right, now let's see the calculation together. We're just going to use the standard area formula, and we're going to find that height. Remember, the height is just going to be, what is it, A sine C? Yeah, there we go. 60 degrees happens to be one of those standard angles, so we know the sine value. The sine value is √3/2. So just plugging everything into our formula gives us this. And then our final answer will be 15√3/4. And that is the area. At that point, if you wanted to go to a calculator, you could, and it could give you an approximation of that area. But this is as exact as it gets. 15/4 times √3, or 15√3/4. Okay, now let's learn a new formula for the area of a triangle. This one is called Heron's formula. So this formula is this, or this theorem says this: the area K of a triangle with side lengths A, B, and C is the square root of this value, S times S minus A times S minus B times S minus C. And here the value S is called the semi-perimeter or semi-perimeter of the triangle. What's the semi-perimeter? It's half the perimeter. Half the perimeter. It's kind of like a semicircle, right? When you talk about semicircles, they're half circles. So here, half the perimeter is going to be half the sum of the side lengths. And that's pretty much it. So if you happen to know all the side lengths of a triangle, then you can use this formula and it'll tell you the area of the triangle. A note about this, I omit the proof here. The proof is a little bit long and technical, but I encourage you to read it in the textbook. It's on page 581. It uses a bunch of things. It uses the law of cosines, it uses the power reducing identities, but they're in the form of the half angle identities. And it uses the standard formula from corollary 1, the one where we use the right triangle trigonometry. So the proof itself is a nice exercise in algebra and trigonometric identities, but it is not the proof used or produced by Heron of Alexandria. So this is not that's not the proof that he came up with. But again, you should read it, see how it works. It's a good way to just see how all these identities and all these laws and theorems can come together. But we're just going to use it. So let's use it in this example here. Here we go. We've got a triangle. We measured the side lengths. The side lengths are 5, 6, and 9. What's the area? All right, you think about it and try to work it out on your own using Heron's formula. Okay, let's do it together. The calculation is rather quick. There's really not too much to do. We just got to compute the semi-perimeter and plug everything into our formula. Here we go. So the semi-perimeter is 1/2 the sum of all the side lengths. That's what I get right here, which gives us 20/2, which is 10. So that value S that appears in the formula, S is 10. Now what we do is we just plug everything in. So we're going to have 10 times 10 minus 5 times 10 minus 6 times 10 minus 9. Do some basic arithmetic here, and you're going to find that this is going to be the square root of 200. And then if you want to simplify that, you can. You could pull out the perfect square of 100, and the final answer is 10 root 2. And that is the area. So it's kind of cool, right? It's kind of cool that you just need to know the side lengths. And if you know the side lengths, then you've got the area of the triangle for free almost. But that's what it is. All right, well, surprise, surprise, that's it. So let's play. You should go try to do the homework now, see if you can work through all the exercises. Um, like I had said, this is a pretty short section, just some extra area formulas. So I'll end it there, and I'll see you all next time. Have a good day.